Good morning to all. In our last class, we have discussed about essential amino acids and non-essential amino acids. We have discussed about the definition. So, essential amino acids which cannot be synthesized by the body but has to be taken in the diet. Non-essential amino acids are the one which is being synthesized in the body. So, no need to consume them in the diet. So those are called non-essential amino acids. So we have total 20 amino acids we have studied. In that 10 are essential amino acids and 10 are non-essential amino acids. So now we are going to remember 10 are essential amino acids. So leaving that 10, the remaining 10 are non-essential. What a trick to remember essential amino acids. So what is that trick? We have many different different sentences or different words. So we have framed out of those the first letter of those amino acids. So either the way or in a different manner also you can remember. The simple one here I am going to teach you. So that is PVT, Tim, Hall. PVT, Tim, Hall. So that is nothing but, so it is just a 3-letter word. You should remember this one so that it will be helpful for you to remember 10 essential amino acids. So here P stands for, we shall see that one. So P stands for phenylalanine. V stands for valine. V is for valine. Next, T stands for threonine. It is threonine. So PVT, Tim, Hall. PVT stands for phenylalanine, valine and threonine. So all these whatever I have written, all these are essential amino acids. So next we'll move on to Tim. So you can remember here. So T is for threonine and this T is for tryptophan. It is tryptophan, isoleucine, methionine. M is for methionine. Understood? So tryptophan, isoleucine, methionine. Likewise, we have Hall and that Hall is for histidine, H for histidine. It is histidine, arginine, leucine. One is L is for leucine and another L is for lysine. It is for lysine. So phenylalanine, valine, threonine, tryptophan, isoleucine, methionine, histidine, arginine, leucine, lysine. So all these are essential amino acids. Leaving them. So apart from these 10, so the remaining other 10 are there. So that is one example we can consider, that is proline. We can consider aspartic acid, glutamic acid, glutamine. All these are non-essential amino acids. I hope it is clear. Leaving this 10, 3, 3, 6, 6 plus 4, 10. So leaving this 10 amino acids, whichever it is there. So all those are non-essential amino acids. So in this way you can remember. So what remember properly, that is PVT, Tim, Hall. This is a code word or a trick to remember essential amino acids. I hope it is clear. So next we'll move on to the next part. So we have discussed about one classification, that is essential amino acids and non-essential amino acids. So which has been given in our NCERT textbook. So one more method of classification is there, that is neutral amino acid, acidic amino acid and basic amino acid. So that also we are going to discuss now. Classification of amino acids. As neutral, acidic, and basic amino acids. Basic amino acids. So this the classification is completely based upon the structure, how many NH2 groups and how many COOH groups are there in the compound. So we know that NH2 group is nothing but an amine group. An amine group, NH2 group is there. So we have an lone pair of electrons which is responsible for the basic nature. So it is little bit different when you study the entire structure of amino acid or alpha amino acid. So that is going to a little bit different. But when you consider NH2 group, it is basic in nature. And when you consider COH group, so it is nothing but we say that it is the acid group. So this is the base group and this is the acid group. So both are present in the alpha amino acid or amino acid we have. Both NH2 group is also there and COH group is there. So how we are going to define them is, so in case of neutral amino acid, in case of neutral amino acid, in case of neutral amino acid, alpha amino acids, having equal number of NH2 and COOH group. So alpha amino acids having same number of NH2 group and same number of COOH group. So such kind of amino acids are called as neutral amino acids. That is we can observe that one in glycine. You can observe here. So in case of glycine, we have one NH2 group and one COOH group. Likewise, alanine, we have one NH2 group and one COOH group. In valine, we have one NH2 group and one COOH group. It is valine, one NH2 and one COOH group. So all these are examples for neutral amino acids. So that is example glycine, alanine, valine, etc. Next one is so we'll move on to the next part, that is acidic amino acid. So acidic amino acid, so it is the alpha amino acid containing alpha amino acid. Since the name itself suggests it is acidic, that means that acid groups are more. which is the acid group, COOH groups are more in them. So alpha amino acids containing 2 COOH group and 1 NH2 group. So we can observe aspartic acid. Will consider aspartic acid. You can observe here aspartic acid. So it is 1 NH2 group is there, 2 COOH group is present. Okay. So if more number of acid groups are there, those are called as acidic amino acids. Likewise, we have one more example. So that is aspartic acid we have studied. So likewise, we have glutamic acid. So we have 2 COOH group and 1 NH2 group is present. I hope it is clear. So we have 2 COOH group and 1 NH2 group is present. So aspartic acid, glutamic acid. So these are the examples. Likewise aspergine. So these are the few examples for acidic amino acids. We'll write the example. Aspartic acid and it is glutamic acid. Likewise, we have basic amino acid. So basic group is NH2 group. So same as acidic there, the definition slight change, that's it. So that is alpha amino acid where NH2 groups will be more than the COOH group. So that is alpha amino acids containing 2 NH2 groups and 1 COOH group. So we have few examples. So we shall see those examples. So that is lysine. We have So lysine, you can observe NH2, 2 NH2 group, 1 COOH group. So lysine is one example. Likewise arginine. So where NH2, 2 NH2 groups are there and 1 COOH group. So that is, it is also an example for basic amino acid. Likewise, we have one more example, that is histidine. You can observe here. So we have NH groups and one more NH2 here, only 1 COOH group. So we can say that it is also an example for basic amino acid. So basic amino acid, 2 NH2 groups and 1 COOH groups. So we can write lysine, arginine, histidine. These are the examples for basic amino acids. So we shall go through the next topic now. So that is physical properties of alpha amino acids. Physical properties of alpha amino acids. So amino acids are usually colorless crystalline solids there. So it consists of both NH2 group as well as COOH group. It consists of. So it is not existing or not showing the basic property as NH2 group is there. So it is not showing the exact acidic property, it also has COOH group. Then also it is not showing that carboxylic acid nature or NH2 group, amine nature also. But it has both the groups together, so it is leading to the formation of an Zwitter ion. So what is that Zwitter ion? Now we shall see now. So we have a amine group as NH2 group is present, and it also consists of COOH group. But alpha amino acid behaves as simple salt. Simple salts. So it is not behaving as amine also, it is not behaving as carboxylic acid also, but it is behaving as a simple salt. And the simple salt, why is the simple salt it is existing? We shall see that. So it is R alkyl group present or side chain present, and we have C, we have H, COOH, and it is NH2. This is our alpha amino acid. This is our alpha amino acid. This can also be written as, I mean the same form, same thing, RCH. We have NH2 group. COOH can be written as C double bond O, O and H. C double bond O, OH it is. Okay. Now, on the nitrogen atom, nitrogen is with 3 bonds, 2 hydrogen and 1 with the carbon. So on nitrogen, we have a lone pair of electrons here. We have 1 lone pair of electrons. So hydrogen, the bond will be broken here. The bond will be broken here, and it is being converted as COO minus because hydrogen is leaving the bonded pair here itself. Hydrogen is moving out without the bonded pair. So oxygen is getting a negative charge and hydrogen is getting a positive charge. This H plus ion is attracted towards the lone pair of electrons on the nitrogen atom. Lone pair of electrons on the nitrogen atom. It will be converted as R CH C double bond O, O minus it is NH3, and we have a positive charge. Why positive charge? Nitrogen is forming 3 plus 1, 4 bonds. So third bond, hydrogen doesn't have any electron. So that already it has 3 bonds. So for the fourth bond, hydrogen doesn't have any electron. So the fourth bond is done by spending its lone pair. So because of that reason, so 3 plus 1, 4 bonds means nitrogen will be having an positive charge on it. So on the same compound, we have negative charge also and we have positive charge also. So this dipolar structure is called as dipolar structure, in the sense both positive and negative charge in the same compound it is there. So we call that structure as Zwitter ion. We name them as Zwitter ion. So Zwitter ion is nothing but it is the dipolar structure of alpha amino acid. The dipolar structure of alpha amino acid is called as Zwitter ion. So we'll write that definition. The dipolar structure of alpha amino acid is called Zwitter ion. Okay. So on the same compound, we have positive charge also as well as negative charge also. Acidic and basic properties of alpha amino acids. Acidic and Basic properties. So alpha amino acids will show acidic properties also as well as basic properties also. So which groups are alpha amino groups? So which groups are responsible for the acidic property of the alpha amino acid, or which one is responsible for basic, we shall see. So don't go with the what basic means NH2 group and acidic means COOH group. Don't go with that one, because now we have seen alpha amino acids exist in the Zwitter ion form. So that is R, CH, so it is NH3 plus and it is COO minus. It is a Zwitter ion form. So alpha amino acids will exist as a Zwitter ion. It is existing as a Zwitter ion. So due to this Zwitter ion or a dipolar structure, so what are the changes, or which group is responsible for acidic nature and basic nature, we shall see. So that is first reaction we shall go through. So CH, we have NH3 and it is plus, we have COO minus. We are adding H plus ion. We are adding H plus ion to the compound, or we are adding H plus ion to the Zwitter ion or alpha amino acids. Now COO minus is there. On nitrogen you can observe a positive charge. A positive charge is there on the nitrogen atom. So H is also H plus. So plus and plus repels each other. We don't have minus charges on this. If at all, if minus charge is there, then only this H plus ion will attract towards that one. So on this carbon also we don't have, and on side chain also we don't have. So the negative charge is present on COO minus group. So it is going to attract, COO minus group is going to attract a H plus ion. So if at all, if it is accepting an H plus ion, then that group or that particular molecule is called as an base. So R, CH, we have NH3 plus, as it is, it becomes COOH. Okay, so we can write accepts proton acts as a base, accepts proton and it is acting as a base. Likewise, so we shall consider, we have added now acid, or this is in the acidic medium, the this process will takes place. So likewise, we have basic medium RCH NH3 plus and it is COO minus. Basic medium we are observing, it is OH minus. Now what happens, we shall see. We don't have positive charge here. Here it is negative, negative. It cancels with one another. And we have a OH minus getting attracted towards NH3 plus. On nitrogen, we have a positive charge. So NH3 plus attracted towards OH minus. How it is attracted? It is attracted. After that, what is going to happen is, so we can write here it is NH2 and H. On nitrogen, we have a positive charge. This is the bond continuation. This is NH3 plus. I have written in this form. Okay. So nitrogen with the NH2 with the two hydrogens and a positive charge. The third one I have written in this form. So nitrogen is more electronegative in nature, because of which nitrogen will be pulling the shared pair towards this side. Okay, so hydrogen will leave, this bond will be bit weaker due to the electronegativity difference between nitrogen and hydrogen. Nitrogen is more electronegative. So leaving the bonded pair, hydrogen leaves as H plus ion. It is leaving as H plus ion. This H plus ion attracted towards OH minus. So the substance which gives out, or which is going to donate or which is going to give out an H plus ion, then that substance is called as an acid. So we can write gives a proton, acts as an acid, giving rise to a proton, so it is acting as an acid. So the product we can write it as RCH. So if it gives away this H plus ion, this bonded pair is going to shift on nitrogen. So because of which, so bonded pair is going to shift on nitrogen atom. So this positive charge is nullified now. So we can write it is NH2, lone pair is back again. So it is COO minus. Okay. So we have a NH2 group as it is. So we can say that now we can conclude that the basic character, we have written the we are studying about the basic acidic and basic properties. So the basic property is due to what? So it acts as a proton, acts as a base, accepts proton, acts as a base. The basic property is due to COO minus group, and it acts as an acid. It is going to give out a proton, and that is due to NH3 plus group. So that is what our conclusion is. The basic character is due to COO minus group, and the acidic character is due to NH3 plus group. Okay, so don't go with the carboxylic acid COOH group and amine NH2 as a basic, but the solution of alpha amino acid will exist in a Zwitter ion form. Because of the dipolar nature, the basic character is due to COO minus and NH3 plus group. Next is, so we have a Zwitter ion formation we have discussed. So based upon that one, we have isoelectric point. Isoelectric point. What is this isoelectric point? We shall discuss. So in we have seen what Zwitter ion formation of an alpha amino acids, that is it is dipolar in nature. So if at all if it is being dissolved in what aqueous solution, an aqueous solution we have prepared, and it is completely neutral in nature, completely neutral in nature. So if at all if there is a change, if it is completely neutral in nature, then the particles doesn't move towards any of the electrode. Suppose if at all if the solution, aqueous solution we have prepared, and the aqueous solution is alkaline in nature, then amino acids exist as negative ion, because we know that. So what NH3 group, NH3 plus group is responsible for acidic character, and COO minus group is responsible for basic character. If at all in an aqueous solution, if it is a neutral aqueous solution, then no problem. If NH3 plus group is more, then it will act as an acidic. So if at all if COO minus group is more, then it will act as a base. Suppose if at all if in an aqueous solution of alpha amino acids is alkaline, is an alkaline solution. If it is unprepared slightly alkaline solution, whatever is prepared, if it is slightly alkaline in nature, then amino acid group. Amino acids exist as negative ion and migrates towards anode, which is a positive terminal or positive electron. Likewise, if at all, if the aqueous solution of alpha amino acid is acidic in nature, alkaline we have written, if it is acidic in nature, then if it is acidic in nature, then the alpha amino acid, so we have amino acid exist as positive ion. Acidic NH3 plus is there, basic COO minus, alkaline is there, so that's why negative. So acidic it is acidic, positive charge, it exists as a positive ion and migrates towards cathode, negative terminal of the battery, and all these will happen under the influence of or under the presence of electric field. Under the presence or under the influence of electric field. I hope it is clear. So now what is this isoelectric point? We'll discuss. But what aqueous solution of alpha amino acids, if the solution is slightly alkaline, then exists as a negative and migrates towards anode. If it is an acidic, then it is a positive ion, migrates towards the cathode. And this all will happen under the influence of electric field. Suppose if at all a pH of the solution is maintained. pH of the solution is maintained in such a manner that the particle doesn't move towards cathode or it doesn't move towards anode, then that particular pH is called as isoelectric point. At a particular pH, the dipolar ion exists as a neutral ion and does not migrate to either electrode. So we have seen, if at all, if it is acidic in nature, then it moves towards the negative electrode. If it is positive, if it is alkaline, then it moves towards the negative, it migrates towards the anode. So if it is acidic, then it migrates towards the cathode. But if at all, if it is neutral, then it doesn't migrate to either of the electrodes. So that particular pH of the solution at which particular amino acid does not migrate under the influence of an electric field is called as isoelectric point of that particular amino acid. So this is what called the isoelectric point. The isoelectric point depends upon the functional group present in the alpha amino acids. Suppose the alpha amino acid is a neutral amino acid. It is a neutral amino acid. That means that it consists of equal number of NH2 group as well as equal number of COOH group it is present. Then, so the isoelectric point is in the range of pH is equals to 5.5 to 6.3. This is for neutral amino acid. Likewise, so we have example also. So example for this one is glycine. So glycine, where pH of glycine is 6.1. So likewise, we have acidic amino acid. Acidic amino acid. So the isoelectric point, the remaining thing as it is, the pH value only I'll be writing. So the isoelectric point, it is ranging from 3.2 to 3.5 it is. And this will be an example, if at all, if it is being considered, it is aspartic acid. Aspartic acid, where pH is between 3, it is exactly, it is so 3 or slightly here and there, slight variation you can observe. So likewise, if at all, if it is basic amino acid, so the isoelectric point, where the pH is going to vary between 7.6 to 10.8. It is 10.8. So we have an example, lysine, where pH of lysine is 9.7. So likewise, if at all, isoelectric point is nothing but it is the pH at which the amino acid doesn't migrate towards either the electrode under the influence of electric field. So it is completely, the isoelectric point is completely based upon the functional group. As it functional group changes, the isoelectric point is also going to vary. So if it is neutral, it is different, as well as if it is acidic, it is isoelectric point is ranging from 3.2. There is a slight change. It is not 3.5. It is 5.4. 3.2 to 5.4. And likewise, if it is basic, so it is ranging from 7.6 to 10.8. So this is what the isoelectric point of different amino acids. So here the classification, that is acidic, basic and neutral, that classification. Likewise, this isoelectric point, this thing is isoelectric point, and the ranges are not there in the NCERT textbook. This is for competitive purpose, it has been taught. So likewise, so this also, this acidic basic properties, acidic and basic properties. You can observe acidic and basic properties of amino acid, likewise isoelectric point, and we have also discussed, that is essential and non-essential we have discussed. Essential and non-essential, it is there for theory. Zwitterion formation is there for theory. That means that what is zwitterion, how it is formed, that is there for theory. The remaining all whatever we have dealt today, so all those are for competitive purpose.